Hello everyone, welcome to Power System Protection course. In this lecture, the topics that we are going to discuss are primary and backup protection and essential qualities of protection. First, we shall see the what is primary and backup protection. So we already know that the power system is divided into various zones for its protection. In the previous lecture, we have discussed about the zones of protection. So for every zone, there will be a protection system, primary protection and as well as backup protection. So if any faults occurs in its zone, let us say some zone, if any faults occurs in a zone, the primary relay, the function of the primary relay is to, it has to trip the, it has to operate and it has to isolate the faulty part from the its protected zone. If due to any reasons, if due to any reasons the primary relay fails to operate, if due to any reasons the primary relay fails to operate, then there will be a backup relay which comes into picture and it will operate and it will clear the fault and it acts as a second line of defense. So primary relay acts as a first line of defense and backup relay acts as second line of defense. So the reliability of a protective scheme should be at least 95%, which means the relay protective relay should operate 95 times out of 100 times. The various reasons, the various reasons the are causes for the failure of the protection system are given in this table. So if you look at this table, this gives the percentage failure rate of various protective equipments. So in this side we have name of equipment, here we have percentage total failures. So first one is relays. So failure of the relays rate is highest, that is 44%, and circuit breaker interrupters, failure of circuit breaker interrupters, that is 14%, AC wiring 12%, breaker trip mechanism failure it is 8%, current transformer failure it is 7%, DC wiring failure it is 5%, voltage transformer or potential transformer failure it is 3%, auxiliary switches, breaker auxiliary switches failure it is 3%, breaker trip coil failure it is 3%, and DC supply to the trip coil failure is 1%. So this table gives the percentage of the failure of the various protective equipment. So if any due to any failure of these protective equipments, the primary relay may fails to operate. So when the primary relay fails to operate, then there comes the backup relay which will operate and which will isolate the faulty fault from the healthy section of the power system. So these backup relays are made independent of those factors which might cause primary relays to fail. So if the primary relay fails, means the input to the primary relay are from the CTPT and measuring units, right? So if the same CTPT are used for the backup relay, then the backup relay will also fails. So the backup relays are made independent of those factors, that is the measuring instruments, that is CTPT, must not be used in common with the primary relay. So the measuring instruments used for the backup relay are different from the primary relays. And there are three types of backup relays. Usually there are three types of backup relays. One is remote backup, next one is relay backup, and third one is breaker backup. So first one is remote backup. Remote backup means uh, this is a type of backup relay which are located at the neighboring stations. Which are located at the neighboring stations. They back up the entire primary protective schemes. So these remote backups located at the neighboring stations, they back up entire primary protective schemes, which includes the relays, circuit breakers, CT, PT, and other elements. In case of failure of the primary protection system, this remote backup will come into picture and it uh, will come into picture and it will operate and it will trip the faulty part from the power system. And it is treated as one of the cheapest and simplest form of backup protection. and it is widely used for the backup protection for the transmission lines. Remote backup is widely used for the used as backup protection for transmission lines. And next we have the relay backup. Relay backup, this is a kind of local backup where an additional relay is provided for the backup protection. So in case if there is any fault, the primary relay fails to operate, then this relay, the additional relay, will comes into picture and it will operate. Though this is a costly compared to the remote backup, because these remote backup are located in the neighboring stations, but these relay backups there will be a additional relays provided. So when you provide additional relay, the cost will be more. So it can be recommended that where remote backup is not possible, where remote backup is not possible, for such backups relay backups are used. And the supply to the relay backup are different from the primary relays. That is, if we are using some CT and PT for the primary relays, they should not be used for the relay backups. Relay backup, relay backups. And third one is the breaker backup, and this is also kind of local backup, and this will be mainly used for the bus bar protection. So this type of backup is very much necessary for the bus bar protection system, where number of circuit breakers are connected to the bus bar. So when a protective relay operates in response to any faults that occurs in the power system, the circuit breaker has to trip the faulty part. If circuit breaker fails to trip, if the circuit breaker fails to trip upon the relay operates, but the circuit breaker fails to trip, in such case the fault is treated as the bus bar fault. In such situations, it becomes very much necessary that all the circuit breakers on the bus bar should be tripped. The breaker backup will come into picture and it will trip all the circuit breakers present on the respective bus bar system. So this is about the uh, primary and backup protection. Next we will discuss about the essential qualities of protection scheme. So here are the basic requirements of a protection system. First one is selectivity or discrimination. Second one is reliability. Next, sensitivity, stability, and fast operation. So if you consider any protective scheme must have these qualities. So we will discuss one by one what is selectivity, what is reliability, sensitivity, stability, and fast operation. So first one is selectivity, or we can call it as discrimination. So which means it is the quality of the protective relay in which it should be able to discriminate between a fault and a normal condition, fault and a normal part in the protected section. If we have some protective zone, in the zone if there is any fault occurs, the relay should identify this part, in this part the fault has occurred, in this part the fault has not occurred. So it should distinguish between the faulty part and healthy part in the protected section. And it also should be able to distinguish whether the fault lies in its zone of protection or outside the zone. So we know that there are different zones in the power system, zones of protection. Relay should identify whether the fault has occurred in its zone or outside the zone, and as well as it should be able to distinguish between the fault currents and the power surges, or the transformer inrush magnetizing currents. So it should be able to distinguish between faults, currents, and power surges. In and We see that the protective relay must be able to discriminate between those conditions for which instantaneous tripping is required and those for which no operation and time delay operation is required. So the relay should discriminate whether instantaneous tripping is required or no tripping is required, or there is a time delay tripping is required. So that is about the selectivity or discrimination. Next point is reliability. Reliability means, so whenever there is fault occurs in the power system in some zone, the relay should reliably operate. The relay must operate reliably when a fault occurs in its zone of production. So if there is failure in any of the protective equipments, like failure of CT, PT, or wiring or battery, the failure rate should be very less. The operation of the relay should be very reliable. So in order to achieve the high degree of reliability, and greater attention should be given to the design of relays, installation and maintenance, and testing of the various protective systems. So in order to increase the degree of reliability, we should give the attention to the design part, installation, maintenance and testing of the various protective equipments. And the reliability rate should be 95%. It should be more than 95%. Next one is sensitivity. Sensitivity means a protective relay should operate when there is a high magnitude of currents, which means protective relays are designed to operate like, if some current exceeds the preset currents we can call it as a pickup values. So if there is a excess current, then the pickup value, then the relay should sense and it should operate. That means the protective relay should be sufficiently sensitive to operate whenever there is operating current just exceeds its pickup value. Pickup value means it is the set value, preset values. Next one is stability. So stability means whenever there is a large currents, whenever there is fault occurs, there are large currents flowing in the protective zones due to an external fault or internal fault. The power system should maintain its stability, that is ability of the power system to remain in synchronism after occurrence of the any faults. So if there is a huge fault occurs on the power system, the faulty part should be immediately isolated from the healthy part, thereby it should maintain the stability of the power system. Next one is the fast operation. So whenever there is any fault occurs in the power system, a protective scheme should be fast enough to isolate the faulty element of the system as quickly as possible. So in order to minimize the damages to the equipments and to maintain the system stability. So relays should operate as quick as possible in order to avoid the damages to the equipments connected in the power system. So the operating time for productive relay is usually 1 cycle, and we have half cycle relays are also available. For distribution systems, the operating time may vary between more than 1 cycle. So this is about the qualities of the production system. That's it in this lecture. Thanks for watching.